Very good morning, all of you. Hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session. In yesterday's session, we took stored functions, right? So we saw what is the special difference between stored functions and stored procedure. The syntax part, then it returns a value that we saw. It will never take out or in out parameter. All the parameters are by default in, right? Then you have to mention deterministic or non-deterministic. Okay, then some examples we solved. Then we discussed about cursor. What is a cursor? So cursor always associated with select query, and it is a pointer pointing to the current record. And cursor helps you to process record by record. It helps you to process result set or row set record by record. Each record, if you want to process individually, that time cursor helps. And there were 4 parts of cursor: declaring cursor, then opening cursor, fetching, and then closing. Okay? After every fetch, you have to check whether the flag is set or not. Now, some more things are remaining that we'll discuss. Now, in today's session, one more concept we have to see related to stored programs only, that is trigger. Okay, so what is a trigger? That we have to see. Trigger is also one type of stored program only. I hope when we started with stored program, that time I told there are 4 types of stored program: stored procedure, stored function, triggers, and event functions, right? So trigger is also a stored program. It's a code block. It is performing some task. It's a code block. It contains logic. It is also compiled and stored into your database, like stored functions and stored procedures. Okay? Only thing is, triggers are executed implicitly whenever any event occurs on a table. And you will say which event I list out. But suppose you have returned that trigger, that is the stored procedure, for that event, then whenever on that table that event occurs, automatically that trigger gets executed. Only that is the speciality. Like stored procedures, we call using a call statement. Functions also we call using select statement or in a where clause, right? But triggers we don't have to call. It is also a stored function. It is also a stored program. It is containing logic. It is performing some task. Okay, this is also the code stored in your database. Only the thing is, these stored programs are not called explicitly. It gets automatically called whenever an event occurs on a table. Correct? Then you will say which event. The events are performing insert operation on the table, delete operation, and update operation. Only for these 3. So whenever on that table, if insert occurs or delete occurs or update occurs, so we say event has occurred. And suppose for that event you have written a trigger, that trigger will get executed. Okay, and in that also you can mention before and after. Means, is your procedure supposed to execute before doing that activity or after doing that activity? Now, as I said, that activity is insert, delete, update. Okay, and before and after. So suppose you have done it, that activity, you have written it for insert and after. So whenever on the table you perform an insert operation, so after doing that insert operation, it will execute it. And suppose you have done it for before, then before doing that insert, it will execute your trigger. Same is the case for delete and update. Okay. So in simple terms, triggers are stored programs. Only you don't have to call them explicitly like stored procedures or stored functions. They get called implicitly whenever any event occurs on a table. And what are the events? Before, after, insert, delete, update. So whenever insert, delete or update happens on the table, automatically the trigger gets executed. If you have written trigger for that event, otherwise you'll say from where it will come. So suppose you have written a trigger for insert. So whenever you perform insert on that table, automatically the trigger will get executed. So what are the syntax? Then uh, what limitations triggers have, all that things we will discuss. Okay, so a trigger is a stored program like stored procedures, stored functions, how they also get compiled and then they get stored in your database, and then whenever you want you call them. Only the difference is stored procedures we call using call statement, stored functions we call in a select statement or in a where clause. Correct? Here we don't just call them, they get called automatically. So a trigger is a stored program in MySQL that is automatically executed. Getting? Now automatically meaning implicitly. It gets, means your system only will give call to it. You don't have to call it. Getting? So it is getting implicitly executed in response to the event on a particular table. So suppose there is a table student, and for insert operation you have written trigger. Okay, so this is your student table, and for insert operation and after you have written that trigger and kept it. It is compiled and it is stored in your database. Okay, but you have told that this is the procedure for this table after insert. Means when you create trigger, you have to tell that this trigger is for which table, for which operation, and before or after. So all that you have mentioned, the trigger is stored now. Now whenever any person inserts a record in it, the moment you insert the record, insert event has occurred. But as you have written after, it will insert the record, and after that it will go to this trigger implicitly, that is automatically. You don't call it, it will automatically get called. This trigger will get automatically called when after you perform insert on this. And same way if you have done it for before or update or delete, it's up to you. Okay, MySQL supports before and after. Should the trigger get executed before that event or after that event? Any one you have to mention. And the events are insert, delete, update. Only for this you can write triggers, remember. For insert operation, for update operation, and for delete operation, not for select and all. Okay. Now we'll see the general syntax of trigger. Now you're creating trigger, and once the trigger is created, it gets recorded in the database as your stored program, like stored functions, stored procedures. Trigger will also get stored. And then whenever the event on that table occurs, automatically the trigger will get executed. Getting? Now the syntax of trigger. As you're creating the trigger, create is a keyword. Then what you're creating, trigger. The trigger is a keyword. Like you're creating table, we write create table. If you're creating function, we write create function, create procedure, create view. Same way, create trigger. Then give some meaningful name to the trigger. Triggers don't take any parameters or anything. Why? Because we don't call them. They get called implicitly. Okay. So create trigger, trigger name. Then you have to tell whether the trigger is to be called before the event or after the event. Means after the event is performed or before the event. So before and after. Okay. And for which operation? Either insert or update or delete. Getting? Any of this. Whether for insert or update or delete. On which table? That's what I said. You have to mention that this table is for, this trigger is for which table, so that on that table, when this operation happens, it will automatically call the code, that is trigger, and it will execute the code. Okay, so I hope you're understanding that the event is insert, update, or delete, and whether the trigger is to be executed before that operation or after that operation, that you have to mention. And this trigger is for which table, that you have to mention on table name. Remember, on this table, when insert happens, or on this table update happens, automatically this code will get executed. You don't have to even call. And the logic is written between begin and end. That is clear to you. Okay. And this is one line which you have to mention, that is for each row. Means you are telling that this procedure is to be executed for each and every row affected by that query. May the query be one. Example I'll tell you, like the query is update query, but the query is written in such a way that it is updating more than one record. One query, but affecting like update student, and we are saying set marks equal to marks plus something where marks less than 40. Now this is such query which is going to update not one record. It may be more than one record. Now less than 40. Suppose there are 10 students who are having less than 40. So this update is going to update how many records? 10 records. So for each record which is getting updated, that many times it is supposed to execute the trigger code. Means it is not going to execute the trigger code only once for one query. Means query is one, so trigger will execute once. Not like that. Though the query is one, but it is updating how many records, that many times the trigger is executed. That is the reason we have mentioned for each row. We have not written for each statement. In some languages, some database management systems like in Oracle and all, they have given provision of for each statement also. So in that case, what it will do, it will execute this trigger body how many times? Only once, irrespective how many records are getting updated. For one query, one time. One query means one statement. So for one statement, one time only it will execute the code. If you have written for each statement, getting? But in MySQL, you only have to write for each row. So if the statement is one, then also it will execute this code how many times? As many rows are getting affected because of that statement. Though the statement is one, but that one statement is affecting how many records? As many records, that many times it is going to execute this code. Getting? So as I said, this query is one statement, but it is affecting, suppose, 10 records. It is affecting 10 records. So 10 times this code will get executed. Okay, so I hope the entire syntax is clear. Before tells that whether this code before and after. So before is telling first run the query, first run the code before doing this operation. Means before doing insert, update or delete, run the code and then do that activity. And if you write after, then in that case what happens? It will perform this activity, that is insert activity, update or delete, and then run the code. Okay. So execute trigger before the operation. Which operation? Insert operation, update operation or delete. And after means first perform the operation. First it will insert the record or update the record or delete the record and then execute this code. Okay. And for each row tells that call this trigger for that many rows as many rows are getting affected because of this query. Like query is one only, one delete command I have given. Okay, I have given one delete command, delete from employee, suppose, where department ID equal to 10. Means I'm deleting all the employees of department 10. So there can be one or more records in employee table who are belonging to department 10. So if there are 10 employees in department 10, 10 times it is going to execute this code. Means for each row, it is going to execute the code. So that is for each row. The trigger acts on each row affected because of that statement. Statement is one, but because of that statement, how many rows are affected? For that many rows, this code is executed. Getting? So that is the main concept. Before, after, I hope you got it. If you write before, then the trigger code is executed and this operation is performed. If it is after, then first it will perform the operation and then run the code. And for each, it says run this code for that many rows, as many rows are affected because of these queries. Getting? How many records got affected because of this query? For that many times you execute this code. Okay, I hope you got it. Then whenever you are dealing with the trigger, inside the trigger only, they give you access to two variables. Okay, they are record type variable. First remember, and they are not true. Why? Because they say these variables are not accessible anywhere. They are not made available anywhere in stored programs, functions. Getting? They're only available within the trigger. Only for trigger purpose these two variables are available, and they are record type variable, meaning in this all the values of the record will come. Okay, as many columns are there, that many fields will be there, and only one row will be there in it. It is like a structure in C, or it is like an object in Java or C++. So suppose that trigger is for student table, and student table is having student ID, then name of the student, marks of student, okay, phone number of the student or whatever. Okay. So as many columns, that many fields will be there in that variable, old variable or new variable, and only one record will be there. Exactly one. It is a variable. Old and new are two variables, and they are record type variables. And these two variables are only available within the trigger. You're not able to access it anywhere, and they are automatically created. And they are available only in the trigger body. You can directly use them. But what do they contain? What does that old and new contain? I told you they are record type. So it will contain only one record at a time in that variable, old variable or new. And as many columns in your table for which the trigger is written. The trigger is written for some table. So as many columns are there, that many fields will be there in that variable. And inside your trigger body, you can access them by putting dot. Old dot SID, old dot name, old dot marks, old dot phone. Same way for new. New dot SID, new dot name, new dot marks, new dot phone. Okay. I hope it is clear. So what does that new and old contain? That I'll tell you. Now, whether it is before or after, and whether the operation is insert, delete or update. So operation is insert, or whether the operation is delete or it is update. Getting? And if it is before or after, whatever it is, let it be before or after. In case of insert, we don't have old, we only have new. Means let the event let be before or after. I'm just telling about old variable and the new variable. Whenever the operation is insert operation, that time we only have new, we don't have old. Okay, and what will be new containing? The record which you are going to insert. Just now the record which you are going to insert is present in that new. The record which you are inserting, that record values are put into this pseudo variable new. So new is containing which values? The record which you are inserting. Old not available in case of insert. Then if you go to delete, we have old, no new. Okay, the record which is getting deleted. The record which is getting deleted is in old and no question of new. In case of update, we have both. The record which is getting updated is in old and the new values which are getting replaced on it are in new. So new contains the new value and old contains the old value. So whenever the event is update, then in that inside trigger, we are available with both. We are available with new variable also and old variable. In case of delete, we are only available with old pseudo variable, no new. Getting? And in case of insert, we are only available with new, no old. Getting? And remember, they two are just variables containing a complete record. Therefore, they are record type variable and you access them with a dot. Okay. And these two variables are only available in the trigger body. Nowhere else you can access. Getting? And what they hold, that I told you, old holds the old value and new holds the new value. So when the event is insert, that time old doesn't contain anything. New contains the record which is getting inserted. The new values which you are going to add in that table, they are in that new variable. In case of delete, new is not there, old is there, and old contains the values of the record which is getting deleted. In case of update, both are there. Old contains the old record and new contains the new value which is going to get replaced on it. Okay? So this thing you have to remember, because now when we'll solve some examples, you'll come to know within that example we'll be making use of this pseudo variables old and new. So remember, in case of insert, old is not there, only new is available. In case of delete, old is available, not new. And for update, both. Okay. Now we will write some examples of trigger. Okay. First example we'll take, that is after insert. Meaning on one table, whenever I perform any insert operation, on any table, if I do any insert operation, so immediately after inserting the record, the code should get executed. Getting? This is some table, and in that table, for insert operation, after insert for that table, whatever the table is. Okay, and this is the trigger. That trigger is containing code, and that is returned for after insert on this table. Okay, so you have written a trigger for this table after insert operation. Now what I'm going to do, I'm going to insert a record in it. So the moment I insert the record in this table, immediately this trigger will get executed. Whatever the code is there will get executed. Now inside this trigger body, the record which got inserted just now the record, that you will be available inside this in new variable, not in old. Okay? Now we'll take an example of it. Create a backup entry in student log table after inserting a new student. So what we'll do, we will have two tables. One is a student table and one is student log table. Okay. So the moment I insert any record in the student table, it should make automatically one entry in the student log table. Okay, we will see that how. Means automatic, when I insert a record in student, it does a insert in log table also. Okay, so two tables will be having. One is create table students. This is your main table having ID and name. ID as a primary key and then name. Second one log table I'm making. Okay, it's like a backup or whatever operations you are doing on this table, it is maintaining a track. Getting like in companies also they maintain a log that when you logged in, when you logged out, again when you logged in. Based on that, they have to keep a track on activities what you do. Getting so how much time you actually work total. So here a log entry is done. Now in the log table there is a log ID because continuously the entries are done for one student, for second, third. Okay, so there is a unique log ID. Then for which student that log entry is done, okay, that student ID, it is a foreign key. That ID of the student will be entered into the student log table. Then what action you did, that is insert. You are inserting the record. Therefore, the action is insert. And the time when that insert took place, that time is also maintained. So it is default time. Okay, so it is of timestamp and the default value is, if you don't give, it will take default value as current timestamp. Current timestamp means current time and date and time. Okay, whatever the current date is and whatever the current time is, that is put here. So what should happen? I hope you got it. See here, I'll pictorially show you. This is your student table. Okay, with ID and the name. Okay, and there is another table called as student log table, in which what will be there? The unique log ID, then the name of the student ID, then what action you took place, and the timing. Okay, and here the date and the time. This is an empty table. This is also empty table. Now what I'm telling is, I'm performing, means I'm writing a trigger, when logic is there, for the student table. Okay, and for which operation? After insert operation. After insert for student, I have written a trigger. Some logic is there. So now what I'm doing is, I'm inserting the record. The moment I insert the record, after insert, I have inserted record 1 Ram. Okay. The moment I insert the record, after insert, it will go to this trigger. Why? Because you have told to the system that this is a trigger on student table after insert. Getting? And triggers, that is the speciality. The triggers are the functions which get called implicitly. Triggers are the stored codes, but you don't call them explicitly. They get called automatic when the event occur. So when on the student table, I perform insert operation, I'm adding one record. So after the insert takes place, immediately it will go to this code because it is meant for after insert on student. Now what we are doing inside that code, we are adding one record in this table. We are adding one record in this table inside this trigger code. Means inside the trigger code, what I'm doing is, the current record which got inserted here the record which got inserted, that record will be available in which pseudo variable? The record which just now got inserted, that record will be available in one pseudo variable, that is new. So from new.id, new dot id. I'll get this id. I'll take that id. Okay. Then action I'll put insert, and I don't have to put time. It will take current time. And log id I don't have to give. It will take automatic, and it will add one record over here. Getting? Action is insert, and whatever the timing is. Understanding? So who is doing the inserting work in this table? The trigger is doing. Trigger is automatically adding one record here. But while adding, it is taking this student ID. Okay. Then action insert, time automatic. Okay. And this ID also auto, because you have given auto increment. Understanding? So inserting record in the log will be done inside the trigger body. But trigger will execute when after insert operation on student table is done. On student table, when we do insert operation, when we perform insert operation on the student table, after doing that, it will go to the trigger, because you have mentioned only that this is a trigger for student table after insert. And this record which got inserted is in which pseudo variable? New. So inside this body, can I write new.id and get this ID? And that ID only I'll use for inserting in this record. Okay, see here. Now first what we'll do, we'll create those tables. Okay. For that, first I'll create one database. Create database trigger DBI. Okay. Use trigger. Okay. You can refresh here. Then we will create one table. Create table students. Okay. Create table students, ID and name. ID, integer, primary key, name, varchar 50. We'll create one more table. Create table student log. Okay, and in that we will add one log ID, integer, primary key, auto increment. Then we will add action, varchar 20, suppose I'm giving. Okay, and then student ID also. Action, varchar, and the time, action time, which will be timestamp, default, current timestamp. Okay. So in this table, when you insert a record, no need to give log ID, it is auto generated, and no need to give action time, it will take the current time. You only have to give the student ID for which the entry is done and the action. Okay. Now that is done. Now we will write first trigger. We'll create a trigger. Create trigger, trigger name. Okay. Create trigger, trigger name I'll give. Whatever trigger name. Suppose I'm giving after student insert. Okay. Before that, delimiter, you know it, $. Now this is after operation, which insert on which table? Students table. For each row, Okay, and then our body, that is begin and end. Delimiter semicolon. Now what we have to do in this, inside this, what we have to do is the current record which got inserted in student. Inside student table, one record has got inserted. Therefore, the trigger is called after insert on student. So the record which is just now inserted, that is available in one pseudo variable new. I'll take that value and insert a record in which table? Student log table. See, insert into student log. Okay, and columns are student ID and action. The other two we don't have to give, right? Log. Values. For ID, I'll take new dot ID, and for action, I'll put a string insert. That's all. Okay, now remember this trigger will automatically get executed whenever you perform an insert operation on students table. So whenever we do insert operation on student table, so after insert on students, it will immediately call this code and it will run this code. And what is this code doing? It is adding one record in log table. Okay, see here. Now we will, first we have to compile this so that the trigger will get stored. Okay. Now let's test it. We will insert one record in students table. Values, see here, 10 and Ram. Okay. Suppose I'm inserting one more, 20 C. I'm inserting two records. So 2 times it is going to execute this code. Okay, and you can check the records currently in your table. See here, select star from students. No record is there. Same way, select star from student log. See, no record is there. Both tables don't contain any record. Means both are empty table. Okay, and now I'm trying to insert two records. So the moment I add two records in student table, there will be two record entry in student log. Okay, and for both, it will take this ID and this ID, use it over there, current time, action insert, and log ID automatic. See here. Now you run this query. Here you will see two records are added. But when you see student log table, there will be again two entries over there. Can you see? One entry for student ID 10 and student ID 20. Action is insert and the time is the default time, the current date and time. Agreed? So can you see when we were adding one record in student table, automatically one record is also getting added in log table. This proves, see, and nowhere we have called this trigger like stored function or stored procedure. Like stored functions and procedure, we call them explicitly, right or no? But here we didn't call it. We have just created and kept the trigger. And we have told that this trigger is for after insert on student. So trigger is created. It is stored in the database. Now, whenever you are doing insert operation on this table, that is students table, you're performing insert, automatically it will call or implicitly it will call the trigger and execute this code. So you can see when one record was getting added in student, automatically one log entry was done. But in the log entry, how we come to know what is the student ID? From this new. Because I told you when you are doing insert operation, new contains the record which is being inserted. The current record which is being inserted is in this new pseudo value. Getting? Okay. So I hope you got this concept. Similarly, we can try for some other activities also, like before update, means before doing any updation. So I want to update student record, and before updation, whatever name you give, it should implicitly convert to uppercase and store it. Getting? So you give in small case, mixed case, anyhow. Before getting updated, it will convert that old value to upper and then store it. Old value means new value. Sorry. Okay. So what we have to do before update trigger. See here. Convert student name to uppercase before updating. So whenever I'm trying to update the student record and the student name, okay, you are issuing query something like that. Update students, okay, set name equal to, and I'm giving name as small Ram or small Ramesh, whatever, where ID equal to 10. So the student whose ID is 10, its name is getting updated to Ramesh. But what I want is before that gets updated, like 10 contains Ram. So before making that Ram as Ramesh, it should make it to uppercase and then store. Means irrespective how you give the value, whatever value you are giving, that new value, let it be in any case, before getting stored in the database, it should get converted to upper and then store. Getting? So now tell me, whenever you are updating the record, the new values are in new pseudo variable, new dot name. Getting? So you have to just convert it to uppercase and again store in new dot name, so that after converting to uppercase, that value will get stored. Okay, and here why before? Because before doing the updation, before the record is getting updated, before that only you convert it to uppercase and then store it. Okay, so very simple it is. The trigger delimiter we have to write, then create trigger name, whatever name you want to give. Okay, then it is for which event? Before update event. On which table? Student table, for each row. See here what you are doing, whatever that new name is, which is yet to get replaced. Why it is yet to be replaced in the database? Because you have written before. So before doing the update operation, it will come to the trigger and then do the update operation. If you would have written after update, then first it will update and then come to trigger. It will come to trigger after doing the updation. But what we want, before doing the updation, first it should come to trigger and convert that name to upper and then give for updation. Okay, so what you are doing, whatever that new dot name is, new dot name contains the name which you are just updating. So it can be lower, mix, anyhow. We are generalized converting to upper and storing in new dot name. And as it is done before only the changes are done. Now after that the updation will take place and it will take this new value. Okay, see, I'll write this trigger also for you. Create trigger before student update. Okay, before update on students for each row, begin, end, $, delimiter, $. Only one line I'm doing. Set new dot name equal to upper. Do we have upper function in string category? Yes. String functions when we discussed in the past session. all the functions in string category: upper, lower, substring, length, replace. Don't remember? Then trim functions, ltrim, rtrim, trim. We have seen it, one complete table. Then in str, okay, reverse was there. So all are string functions. See, new dot, okay, and delimiter, semicolon. Coming back to our origin. First I'll compile it so that it will get stored in the database. Okay, now the trigger is created. We'll test it. See, I'm trying to update students set name equal to RAMESH where ID equal to 10. Okay, previously we have seen the result. See, we have 10 RAM, 20 CETA. So what I'm doing is I'm trying to update the name of ID 10, that is this RAM, to Ramesh. But while giving, I have given Ramesh small. So that value is in new.name. New.name contains Ramesh. We convert it to upper and then the updation takes place. So it will take that new value. Okay. Now record updated. Now just check. Okay. See. Is it making Ramesh capital? 10. Ramesh is completely in capital. So Ram got replaced with Ramesh with, irrespective, you have given it as small Ramesh, but before doing that updation, it has gone in the trigger. Before doing this updation work, does it go in the trigger? Yes, because you have told that that trigger is before update on students. See here, before update on student. So whenever you are updating any record in the student table, it will first come to this trigger. But inside the trigger, what you have done, the new name you have converted to upper. But that's all. And now the update will take place. But when the update takes place, it takes this new name, which is upper converted. Getting? Like Sita. Here I'm doing this way, 20. And I'm giving Sita, SEETA. Anyhow I'm giving, doesn't matter. And if you see the records now, are they updated? Yes. Okay. Then one more we'll see, that is for after delete. One more example, like I'm deleting a student record, so it should automatically make one entry in the log that student with this number has got deleted at this time. Okay? So I'm going to delete one record from student table. So the moment record gets deleted from the student table, it should go to the trigger. And inside trigger, what we should do, we should add one log entry. But in that log entry, we need two things, the ID and the action. Action we will give delete, but ID we want, so that will get from our pseudo records. But in case of delete, we'll get from old, not new. So I'll get it from old.id. Old.id will contain the ID of the student which is just getting deleted. The record which is just getting deleted is there in old, and the record which is just getting inserted is in new. And in case of update, the new value which you are going to replace are in new, and where you are going to replace, that is in old. So can I take this old.id and the action is delete and insert a log entry? Yes. See, track deletion of a student means when the student record is deleted, automatically make one log entry that so and so number student at this time has got deleted. Getting? See, delimiter slash create trigger name after delete on students table for each row. And what we are doing, we are inserting one log entry. And in that log entry, two things we need. Log ID we don't need, it is auto incremented. And time we don't need because it will take the current time. So student ID and the action. Action is delete. But from where I'll get the ID of the student which is just getting deleted, the student which is just getting deleted, that record is in old pseudo variable. From that I'll take ID part and add a record. Okay? I hope clear. Delimiter $, create trigger name I'll give like it is after student delete. Okay, after delete on students for each row, begin end, delimiter semicolon. Now what we have to do, we have to insert one record into student log. Okay, and which two values we have to give? Student ID and the action. Okay, values. That ID I'll get from old.id and action I am going to give, that is delete. Okay, I'll compile it and store it in the database. The codes get stored. This is the specialty of stored program. The programs are only stored in the database. Before that, we saw that we can only store records. Right or no? In tables, we are allowed to store the record. But MySQL gives provision of storing the entire logic also in the database, so that the logic is kept in the centralized place and everyone can use that logic if they need. Reusability takes place. Okay, now let's test it. What I'll do is I'll try to delete student with roll number or ID 10. So delete from students where ID equal to 10. Okay, the moment this query is issued on student table, it will delete one record from the student table with ID 10. And immediately it will come to this trigger. Why it will go to the trigger? Because for this table, after delete, you have written this trigger. This trigger you have written after delete on student table. And you are performing delete operation on student table. So the moment you perform delete operation on student table, it goes to the trigger and performs this. Okay, see here. Now check the record in student table. That one record is gone, 10 Ramesh. Can you see only 20 Sita is there? Now check in the log, one delete entry is also done. Can you see? Third log entry for which student ID 10, which entry delete entry at this time. Okay? I hope you're understanding. So this way you can write triggers for different actions. Okay? Then you want the list of triggers, then you want to drop the trigger. Then they have given some commands like view all triggers. Just say show triggers. As we say, show tables, show databases. Same way, show triggers. It is giving the list of all the triggers which we have created. So we have created 3 triggers till now. That is after student insert, after student delete, before student update. Correct? And suppose you want to drop the trigger. You can drop it. As we drop table name. Same way drop trigger name. Just you want it as a confirmation. Then you can add if flag like drop trigger if exist and then the trigger name. I hope you remember if not exist, if exist. This we have used at the time of creating table in the very beginning. or while creating database. See here, drop trigger if exist and then the trigger name. The trigger will be dropped. Okay. Now we will just quickly go through the trigger restrictions. Getting? And then the trigger part will be over. Then we will see the next concept, what are remaining. The restrictions on trigger are that triggers don't take any parameters because we don't call explicitly. So therefore, no parameter. Then the procedures or the functions which are returning something, those cannot be called inside trigger body. Suppose you have written a function or a procedure separately, you have created and kept, and the procedures which are returning something, then such procedures you cannot call inside the trigger. And for one event, one table, you can have only one trigger. Like if there is a student table, for insert operation, after insert on student, you have written one trigger. So you cannot write one more trigger for the same event on the same table. So for same table, same event, only one trigger can exist. Correct? And see to it that for which event you have written a trigger, don't try to generate the same event within it. It will go into a recursion. Okay. If you have written a trigger on some table, like this is a student table, and this is the trigger code. Okay, and this trigger code is for after insert on student table. So on student table, after insert, you have written a trigger. Now what they say that within that body, don't try to issue the same command. Because now see, on the student table, I'm performing one insert operation. I've performed insert operation on the student table. The moment I perform a record in the student table, it goes to the trigger. Because you have mentioned that this is the trigger after insert on student. So the moment you insert the record, after the insertion is done, it goes to the trigger. Because there is a trigger for after insert. It comes inside. But inside what you are doing, you are generating an insert query on the same table. So when you are writing an insert query on the same table, it will go into recursion. The moment you do insert, it will again call the trigger because you are doing insert on the same table. So when you are doing insert on the same table, it will again call the trigger, same trigger, again insert. It will go into a infinite. Therefore, such thing is not allowed. Like if you are writing a trigger for some event on a table, don't try to generate that event within the trigger body. The same event you don't try to generate within that body itself. So that what happens if you're generating the same event, it will keep calling the trigger. It will keep calling the trigger. It will go into an recursion. Okay, so that are few limitations you have to remember. Like, cannot call stored procedures that return result. Means within the trigger body, inside the trigger body, you cannot call store procedure which are having out or in-out parameter. Those which are having out parameter, in-out parameter, such type of procedures cannot be called. Because if they are giving out something where to collect, because trigger we don't call explicitly, they are getting automatically called. So as they are getting called automatically, we don't have only the control on the return value. Getting? Then cannot use transactions like commit, rollback, that type of operations not allowed. And only one trigger per event per timing combination. That is combination of before insert, before delete, after insert, after delete, and before update and after update. Only these 6 combinations on one table. So you cannot have multiple for the same event. Like before insert on that table, and again one more trigger you wrote before insert on the same table is not possible. Okay? So only one trigger per table per event and timing combination. Okay, and cannot modify the same table from within the trigger. As I said, if you have written a trigger for after insert student, so when you're doing insert on student, it goes to the trigger, and inside trigger only again you are generating an insert query. So it is not valid. It's not wise to do that. Okay, okay. So cannot modify the same table from within its trigger, because within the trigger body only, if you are trying to modify the table, it will keep calling the same trigger again and again. It will go into recursion. Okay, so that was all about trigger. Okay, so what are triggers? They are also stored programs. Only the specialities, you don't call them like stored procedures and stored functions. They get called implicitly whenever event on a table occurs. And then the event combinations I told you, after and before, insert, delete, update. The syntax I told you, examples we saw, restrictions. Restrictions they generally ask in interview. Okay. Now we will dive into one more topic, that is view. So what is a view? Okay. You can say view is like a virtual table created from the columns of multiple table. Means already we have one table, then the second table, and I want some selected columns from this table and selected columns from this table. And in the result, I should be able to see the columns from multiple table. Okay. But now some may say this, we do it in joins also. But what I want to say is, view just create a query for it. Okay, and the query will get stored in your database. This is the query storing mechanism. Means it will not create a table from multiple. It will just create a query for this result. I want such a result where there are some columns from one table, some column from another table. And I want to create some imaginary table containing values from different table. Okay, so it is not going to create in reality, or physically it is not going to create a table. For that table, it will just create a query, a select query, and that select query gets stored. And see, till now we have seen that select query gets directly executed. Right or not? Till now we have seen we submit the query, MySQL takes the query, executes it, gives the result. The query is lost. Again, if you want, again you have to submit the query. So you submit the select query, it goes to the database, database executes that query. For that query, it produces the result, gives it to the end user, and the query is lost. In this case, what we can do, we can write select query, which is producing such virtual result. Few columns from one table, few columns from another table. It will take and create a virtual table. But this virtual table, as it is virtual, it is not going to take physical location. Rather, it will create a query for producing this result, and the query itself is stored. And then whenever you want, you can run that query. And when you run that query, it produces this hypothetical result. By pulling the values from multiple table, it takes that value and generates and gives you. The benefit is what? Whenever you want, you can run that query. The query itself is stored in the database. You don't have to type the query again. Getting? And suppose it is frequently needed, the frequently needed activity for some if we are producing some dashboards, and on that dashboard for we need to fetch the records. Okay, so that time frequently we need that query. So why to type that query again and again? Just you can store that query, and that query is stored in the centralized database. Whenever we want, we tell the DBMS that take that query and execute it. So runtime, when it executes, that time it pulls the value from the physical table and creates a virtual table for you and shows. Getting the benefit, what you get is you can make use of that query any number of time whenever you want. And it gives a feel as if it's a table. In reality, it is not a table. It is just fetching the values from different table and presenting to you. Okay, so it is somewhat like we have seen till now stored program. The logic is stored, right or no? If else, loops, inside loops, we have queries. So that whole block, stored program, stored function, okay, trigger, they get the logic is stored. Here the query itself is stored, and only the select query. Yeah? It can be any complicated select query. It can be a very simple query, or it can be a join query, query with group by, having, order by, limit, whatever, nested query, but only select query. Okay, and that select query gets stored, and whenever you want, you can run that query. So in reality, is the table stored or the query stored? The select query only is stored in the database. Okay. So what is a view? A view is a virtual table. Why we should call virtual table? Because it doesn't exist physically in the database. Runtime, it just pulls value from different tables. And after pulling the value from different table, it just presents you as if it's like a table. But it is not in existence. It is physically not existing. Runtime, it is just running the query of that view, the query which is stored in the database. It runs the query pulls the value from different table and presents it. But we feel as if it is like a table. Okay? Why? Because the query is stored with some name. We write a query, we give some name to it. And that name you use as if it's like a table name. Means you are creating a query, a select query. Okay? And you are giving some name to it. Okay? And with that name it is stored. Later you are using that name as if it's like a table name. It is like a table name we are using, but it is not a table. It is just a query. So when you're using that time the query runs and it shows you the result. Concept you are understanding? Okay. So a view is a virtual table. It is created using a select query, and it doesn't store records. It is not actually storing record. It only stores the query. Stores logic, not actual data. But then the data is fetched runtime from different tables which you have mentioned in that query. Whatever tables you have mentioned in the query, it will fetch the value from that different table, and then runtime it will show you the records as if it is like a physical table. Correct? So it is dynamically fetched from base table, means the tables which you have mentioned in that query. The tables which are mentioned in the query, from that it will fetch the value. Okay. So you can give a systematic definition. A view is a database object like table or like function, like procedure, or like trigger. It is a database object. But this database object is not representing physical records like table. Table is actually representing the records which are stored in it. This view is actually representing a stored query. And when you use this view name like a table name, runtime that query is executed and the records are fetched and it presents you as if it's like a real table. Okay? So a view is a database object that represents the result of a stored select statement. See here, the select statement itself is stored. So when you create a view and when you create a table, there is a difference. When we create a table, the actual records are stored. And when we create a view, the query is stored. Though when you use them, both are used as if they are like a table. Table is used like a table only, but view is also used like a table. Getting? But view is not containing the actual physical records. View is just containing the select query. And runtime, the query which is stored in that view will get executed. Getting? So view is a database object that represents the result of a stored select statement and can be queried like a table. Means you're using it as if it's like a table. But though you're using it like a table, but it is not containing records. It is containing only query. And when you're using that view like a table, that time when you're using runtime, that query gets executed and it fetches runtime that value and shows you. Getting? So remember, when you say table, it is actually containing records. The data is there. But when you tell about view, only the query is stored. Storage is there. But in both, what is stored? In table, the records are stored. And in view, the query is stored. Query itself is stored in your database. That is the speciality. Getting? So, a lot of benefits you get by this. Like some columns you want to hide and only make visible the columns which are relevant. Getting? So you're creating a query and in that you're only fetching those columns which are relevant. Those which are to be hidden, you're not showing. And then you create a view and then that view you're using it as if it's like a table. Getting? And centralized place it is kept. So anyone else if needs that view, they can use it. Getting? It avoids writing the same query again and again. You can just write the query and store it, and whenever you want, you can run that query. Getting? A lot of benefits you get, I'll tell you. Security. Hides sensitive columns. Means some columns which you don't want to show, that you can hide it with the help of view. Because in the view, you're going to give the query. And in that query, don't mention only the columns which are not to be made visible. Okay, simplicity. Reduces complex joins and all. So if there are many complex joins, so why to unnecessarily write that joins again? Write it once only, and when you need that joins again and again, just use that view as if it's like a table. Getting? You get reusability. Write once, use many times. You will write that query once, store it in the database, and as many times you want, you can use the view. You're using view as if it's a table, but reality it is only containing the query. Runtime the query is executed. It fetches the value from different physical table and it creates a virtual table and shows you. Okay. Consistency, why? Because it's kept in a centralized place. So everyone will not be creating their own queries. Everyone will be using the same query. So consistency is there, centralized business logic. And whenever you want to create any dashboards and all, and in that the same query will be needed again. So views will be helpful, ideal for dashboards and reports. Okay, views act like a clean interface over messy tables. Means where we have to create a join of multiple tables. So you create all that joins and give a name to it as a view, and then later that whole query not necessary again. Just use that view name like a table name, and automatically the query which is there in that view will get executed. It will fetch the value from different table, create a virtual table and present you. Getting? Now we'll just see the syntaxes of how to create view. Okay, so first we'll see how to create view. Now as we are creating some database object, we have to start with create only. Getting? Like create table, create view, create procedure, create function, create trigger. To create view, view name, some meaningful name. This name only will act like a table name, but reality it is not a table. It is just containing the query, but it behaves like it is a table because you are going to use it in your normal queries. Understanding, guys? in the normal queries, you will use them as if it's like a table name. Okay, so create view name as, and then you will write a select query for whatever task you want. Means that query can be a join query having some columns from one table, some column from another. It's up to you what query you want to write. Correct? Example, see, I'm writing create view EMP basic, where it is fetching employee ID, name and department from employee. So from employee table, only this three columns I'm showing. Okay, and how to use it as if it's like a table. See, select star from EMP basics. See, when you're using it in your select query, you're using as if it's a table, but actually EMP basic is not containing physical record. It is containing a query. So when you're using it in any query, the query which is stored in it will get executed and it will create a virtual table. And this select will be performed on that virtual table. Okay. And if you want to remove the view, drop. Okay, drop view name. And if you want to see the list of all views, we have show full tables where table type is view, because view also come under tables category. So view full table where table name equal to view. This table name is a column in some system table. In some system table, this is a column name. So in that column, all the entries which are having view, only those entries will be displayed. Correct? So remember, views behave like a table. And checking whether the view is there or not. So show, create, view name. So if the view is already existing, it will give you message accordingly. See, like we'll create a view in some sessions. I hope we have done for some join examples of join. If we have taken, I'll go in that database only. I think we have this company DP. Anyone, when we took join that time also we have used. Okay, anyways, we'll take this example. I'll go into this net-to-net database. Okay. Now I just want to show the ID, name and their department. Other things I don't want. Okay. So you can create a view like that. Create view, EMP view as, then select ID comma name comma department from employee. Okay, the view is created. Let's use it in some query as if it's like a table. So select star from EMP view. So remember, when we created EMP view, it looks like a table, but actually the query is stored. And when I use this view like a table in my query, that query will get executed. Okay? Is it only displaying ID, name, department? I am writing select star from EMP view. So the query in that EMP view got executed. And what is there in that query? Only ID, name, department. Okay? You got it. Suppose you want to drop, you can drop, or you want to just see show full tables. Okay, where table type equal to view. Only one view is created. It gives that in the list. EMPVW view. You can create a view with the complex joins and all also. See, or view with a where clause, like here. I want to create a view which will display only the IT employees. So I'm giving department equal to IT. Or view with joins, like we have a customer table and the order table. Okay, so from the order table I want order ID, order amount, and from the customer table I want customer name, that customer who has placed that order. Okay, so we are joining order with the customer, and on which column? There is some common column between them, that is customer's customer ID is present in order also. Means inside order there is a customer ID which is equal to customer's customer ID. Correct? You can have view with aggregations also, like in which there are aggregates as well. See, select department and department wise average salary. Department wise average salary from employee, and you're grouping it by department. I'll create it here. See, department wise average salary I want. Okay, so I'll create a view like that. Create view department DPT AVG sal view. Okay, as, and then we will write query like this: select department comma average of salary. Heading you can give average from employee and group by department. Okay, view is created. Let's use it. So I'll just write select star from DPT AVG sal view. So see here, am I not treating it like a normal table? Okay, but reality this table is not having any records. It's only having query. Runtime the query will run and it will fetch the values from the physical table, create a virtual table and give it to you. See, is it creating? IT, average salary of IT, HRs, finance and marketing. Okay, so this way you can do it. And you can even do update operation also through views. Through views, update also is possible. Getting? However, a view is updatable only if it meets certain conditions. What those conditions are? No aggregate functions. Means in that view, if there is an aggregate function, then you cannot do update operation. Okay. Then no distinct group by or having. Whatever query is stored in that view stores the query. So in that query, if there is group by, having, distinct, we cannot do. No subqueries. Okay. So if it is a simple select query, then through that we can do update. Okay. No joins. Getting? Like I'm creating update EMP basic, set department equal to admin, where employee ID equal to 2. So I'm assuming that this is my view. Okay. Example will take, we already have one view. So this was the view, this view. EMP view, in which ID, name and department is there. Okay. See here, you can check. ID, name, department. Through this, what you can do is, you can modify or delete or something. Like suppose I'm trying to modify Amit Sharma to AMEET. Name I'm updating. ID 1. But through view I'm updating, not through the original table. See, update EMP view, set name equal to Amit SHAR Sharma, where ID equal to 1. Getting? So here it is actually going to update the physical records via this view. Okay. Now one record is affected. Now you can run and see this view. Can you see that Amit Sharma has become AMEET Sharma? Okay. So I hope you got it. That concept is clear to you, right? Now, for today, we'll take a pause over here only, and then in one session, in the next session, we will be solving some exercises. Okay, exercises based on all the concepts which we have learned. So, all the concepts which we have learned till now, that will try to apply. Okay, so I'll take some exercises, and if possible, I'll keep adding exercise sessions for you people. Okay, I'll just keep recording the exercises, and we'll just keep providing you. You can just watch them and improve your skills by solving as many exercises as possible. Okay, but the basic conceptual things are this much. Okay, so for today, we'll take a pause over here only.